It's no surprise to anyone today that land masses are actually able to shift and move around to some extent. Remember Pangaea? Well, it was a continent that existed almost 300 million years ago that broke up into North America, South America, Africa, and Europe. And humans didn't have anything to do with it. The land simply separated and formed into the separate continents we know today. But how are these shifts occurring, and what can we expect from such drastic changes? Stick around to learn more if you're wondering how this could affect you. Almost every area of science has had at least one mystery that seemed impossible to solve. Why do ice ages happen? Why do emperor penguins walk 80 miles inland in the dark and cold Antarctic winter to lay their eggs when it's 40 degrees below zero? Why is the North Magnetic Pole of the Earth moving at more than 40 miles per year toward Russia? Why do old maps of Antarctica show features that are below the ice long before the continent was found in 1820? Why do we find frozen Siberian mammoths with plants, flowers, and seeds from the summer still in their mouths and stomachs? The answers to these kinds of questions show that mass extinctions and the end of civilizations have been caused by catastrophic pole shifts in a regular and predictable way for tens of thousands of years. Pole shifts are global disasters that happen when the entire outer crust of the Earth moves all at once, like a chocolate around a cherry over the layers of liquid rock below. Areas near the North and South Poles move by thousands of miles toward the equator, which of course causes ice caps to melt in warmer latitudes, while areas near the equator move away from the tropics and into colder climates. Some places that used to be warm end up at the new poles, where they get a sudden deep freeze and will soon be covered by new ice caps. As land near the equator moves into the equatorial bulge, it also sinks below sea level. At the same time, land that used to be underwater rises to the surface for the first time in a long time. Changes in latitude and altitude that are big enough to be mistaken as the apocalypse are accompanied by earthquakes and tsunamis that can bring space-age civilizations back to the Stone Age. And this isn't just some crazy idea, by the way. History professors, electrical engineers, and naval admirals have all written books about pole shifts. Albert Einstein wrote the foreword to a book that talked about how mass imbalances cause a movement of the Earth's crust over the rest of the Earth's body, and this will move the polar regions toward the equator. Sir Isaac Newton said that a mass imbalance like this would cause the poles to move around the globe because the mass would always try to move away from the center of its motion. Since then, dozens of scientists have found evidence that pole shifts have happened before and will happen again. Professor Charles Hapgood was one of the most well-known people who came up with the idea of the pole shift. Even though he wrote several books on the subject, including Earth's Shifting Crust, Maps of the Ancient Sea Kings, and Path of the Pole, he kept changing his mind and making statements that seemed to contradict each other when it came to saying how quickly a pole shift could be catastrophic. In his book Path of the Pole, he talks about Ernst Deutsch's book Polar Wandering and Continental Drift, in which Deutsch argues that pole shifts happen very slowly. He then talks about how Deutsch found evidence in Scotland of a crustal shift happening several orders of magnitude faster than he thought it should happen, which he assumed could have been thousands or tens of thousands of times faster. Hapgood wrote that from what they could tell, the pole moved from its old home to its new one very quickly. It must have made the change in a much shorter amount of time than a millennium. So was Hapgood giving in to politics and peer pressure from academics who only accepted very slow changes that fit their uniformitarian models and ignored evidence of sudden disasters? Or was he not telling the truth because of something more sinister? At some point, Hapgood stopped being careful and started to take risks. Since he used to work for the Office of Strategic Services, which was the CIA's predecessor, he should have known better. In 1982, Hapgood wrote a letter to When the Sky Fell co-author Rand Flemath about a new book he was working on. In the letter, Hapgood talked about how the new book would have exciting new material that went far beyond the cautious commentary of his previous book. He told Flemath that he had strong proof of a whole cycle of civilization in both America and Antarctica which pointed to high levels of science. Hapgood might have found evidence the government didn't want to be made public because he was hit by a car and died before he could publish his new work. Whether this was just bad luck or planned is not something we'll ever figure out. Surprisingly, he isn't the only one who believed that the pole shift occurred instantly and caused massive destruction. In the lesser-known book by Chan Thomas called The Adam and Eve Story, the author explained his theories, one of which discussed the shift in the poles. The original book isn't available, but the CIA did publish a sanitized version of it, so you can imagine just how much of its crux is actually missing. So who was Chan Thomas, and why was his book censored so heavily? What information could it contain that the CIA decided to get involved? Thomas presented evidence of a coming shift in the Earth's poles that creates a cataclysm, and he added that these pole shifts are cyclical. In fact, at almost regular intervals, some kind of natural disaster wipes out almost all human life, and we start over again from scratch. He believed that the current civilization is the sixth advanced civilization to evolve on Earth, and many more may have been even more civilized and advanced than we are today. But it's not easy to confirm because the further back one goes, the harder it is to know for sure, mainly because some of these civilizations lived on continents that no longer exist. Regardless, to Chan the situation seemed clear. He believes the pole will shift, but instantly, and when it does, destruction will follow in its wake and obliterate everything in its path. There will be no warning, just a low rumble that will grow from being inaudible into a thunderous roar. That's when the earthquake starts, only it's not like any earthquake in history. In California, mountains will shake like ferns in a breeze, while the Pacific will move back and pile up into a mountain of seawater more than 2 miles high, after which the entirety of it will race eastward. This aqueous mountain will follow the wind that's moving at 1,000 miles an hour and bury Los Angeles and San Francisco as if they were but grains of sand. The reason for such violent wind is that the Earth spins about 1,000 miles per hour, but we don't feel this because everything is spinning together: the land, the water, the atmosphere, and everyone on it. Thomas believes that when the pole shift will happen, the Earth's air and water will continue to spin, but the land masses stop in many places. That's when the Earth's molten sublayer will also break through and spread out a sea of white-hot liquid fire. In a fraction of a day, all traces of human civilization will have disappeared. The fury will march on for 6 days, and on the 6th day the ocean will start to settle. The Bay of Bengal basin just east of India would now be at the North Pole, while the Pacific Ocean just west of Peru would end up at the South Pole. New ice caps would begin to form in the newly formed polar areas. That's when Greenland and Antarctica, which are now rotating equatorially, will emerge with verdant tropical foliage. Yes, this sounds like the end of the world, but this isn't the only shift that should have you worried. Another shift in the poles that are finally being talked about today is the magnetic shift of the poles. Another possibility that we might have to deal with is the problem that comes with the weakening magnetic poles. And no, it won't take 1,000,000 years, nor even 1,000, but only the next couple hundred. If the Earth's magnetic field were to weaken a lot, it could collapse and change magnetic north to south and south to north. And the world would be in a lot of trouble if this goes on, which it will, whether we like it or not. It's just nature, which is also what makes it even more terrifying. The fact is, we may be heading straight for this. Dr. Nicolas Thoveni from the European Centre for Research and Teaching of Environmental Geosciences in Aix-en-Provence, France, explained that the geomagnetic field has been weakening for the past 3,000 years, and if it continued to weaken at this rate, humanity would find itself in a critical situation in less than 1,000 years. Dr. Thoveni is one of the main people in charge of the Edifice project, which has been going on since 2014. He and his co-workers have been looking into the history of the Earth's magnetic field, like when it has switched directions in the past and when it might do so again. The main thing that causes our planet to have a magnetic field is the flow of liquid iron inside its core. It has always been a part of Earth, but its polarity has changed many times over the planet's history. Each time it flips, which has happened up to 100 times in the last 20 million years and can take up to 1,000 years to finish, it leaves fossilized magnetization in rocks on Earth. By using a drill to take cores or columns of sediment from the sea floor, which look like straws and can go down to 300 meters, we can look back in time and see when these changes happened. Dr. Thovany and his team looked at two types of elements that gave them more information about the history of Earth's magnetic field. For polarity to change, the magnetic field must weaken by about 90% to a certain level. This can take thousands of years, and during that time, our planet's lack of a magnetic field lets more high-energy particles from other parts of the universe, called cosmic rays, hit us. When this happens, more and more of the atoms in our atmosphere, such as nitrogen and oxygen, get hit by cosmic rays. This makes things like carbon-14 and beryllium-10, which are called cosmogenic isotopes, fall to the surface. By looking at how many of these are in the cores, we can figure out when the polarity changed. It sounds simpler than it really is. Between 772,000 and 774,000 years ago, there was a change. Since then, the field has almost flipped the other way 15 times. This is called an excursion, and it happens when the field's strength drops a lot but doesn't quite reach the threshold it needs to reach before going back up. When the field starts to weaken and then gets stronger again, this is when we are at most risk. The last excursion occurred almost 40,000 years ago, and there are signs that we are on our way to experiencing it once again. Dr. Thovany said that the geomagnetic field has lost 30% of its strength in the last 3,000 years. Yes, that's not good. Based on this number, his team believes it will drop to near zero in a few hundred years or 1,000 years. And for those of you who want more evidence, we can already see how a weakening magnetic field is affecting our satellites in space. Between South America and Africa in the Atlantic Ocean, there is a large area where the Earth's magnetic field is about 3 times weaker than at the poles. This has been named the South Atlantic Anomaly, SAA, and Professor Chris Finlay from the Technical University of Denmark, DTU, near Copenhagen, is in charge of the CORSAT project, which is researching it. This project is trying to figure out what is causing the SAA by using data from several satellites, such as the 3 swarm satellites launched by the European Space Agency in 2013. Professor Finlay knows that this area is where satellites often have problems with their electronics, and they don't know where this area of weak field comes from, what makes it, or how it might change in the future. Scientists first noticed the SAA in the 1950s. Since then, it's moved closer to the west and lost another 6% of its strength. Professor Finlay and his team are still unable to offer a satisfying explanation for it. He also said that scientists haven't been able to predict how it will change later either. The CORSAT project wants to change all of that by studying the magnetic field and how it changes over time by using the most detailed data researchers have gathered so far. By looking into the SAA, the team hopes to find out what might be happening inside the Earth's core to cause it. One possibility is that there's a large anticyclone in the southern part of Earth's liquid metal outer core, which could be pushing the magnetic field away from the South Atlantic region. Another possibility is that the magnetic field in this area is pointing in the wrong direction, which would be like a small change in polarity. The SAA gives us a direct look at how a weaker magnetic field can affect satellites. Many spacecraft have reported electronic problems when flying over this area because cosmic rays hit them, but it's not clear yet if the SAA has anything to do with the reversal of Earth's magnetic field, which Professor Finlay and his team will also look into. He added that in some simulations, they can see things like the SAA growing when the poles switch. It doesn't have to be the case, but it wouldn't be surprising if something like this was involved in a magnetic reversal. Still, the SAA might give us a hint of what will happen in the near future. If things keep going the way they are, the Earth's magnetic field could flip again in 1,000 or 2,000 years. Before that, the field might keep getting worse and we might have big problems in 100 years. Dr. Thovany did add that the decrease in the geomagnetic field is much more important and dramatic than the reversal of the poles. He's sure that it's very important to know if the current field will fade away to nothing in the next 100 years because we will need to get ready. Doesn't make us feel any better, does it though?